Have you ever stopped to think about how your banking app just knows your balance instantly? Or how your social media feed serves up exactly what you want to see? Well, there's a kind of hidden language running our entire digital world. It's called SQL. And in the next 5 minutes, we're going to pull back the curtain and show you how it all works.
Here's how we'll do it. First, we'll look at the massive problem of data chaos. Then, we'll see how databases create order. We'll meet SQL, the language we use to talk to them, learn its most important words, and finally, you'll see how it's secretly running pretty much everything you do online.
All right, first things first. We have to understand the problem. We are absolutely drowning in data, living in a kind of digital chaos that desperately needs some order.
I mean, think about it. Every single click, every purchase, every single like, it all creates more and more data. But just having all that information isn't enough. The real trick is making sense of it. How do you find one specific piece of information in that giant digital ocean and do it instantly and safely?
Because, managing that raw data comes with some massive headaches. Without a good system, you'd have to write a totally new, really complex program for every little question, like how many people from Ohio bought a red shirt last Tuesday? And what about when two people try to book the very last seat on an airplane at the exact same second? Or if the power cuts out right in the middle of a bank transfer? You need a system that can handle all that messy, complicated stuff for you.
So how do we fix this? Well, we bring in a librarian. Let's talk about the elegant solution that brings order to all this chaos, the Great Data Library. Now, the official fancy name for this library is a Relational Database Management System, or RDBMS for short. But really, just picture a huge, perfectly organized digital library. Instead of messy stacks of paper, everything is filed away in these neat tables. You can think of the tables as bookshelves. Each row on that table is like a single book, and each column is like a specific piece of information about that book. Its title, its author, the page count.
Okay, let's make this real. Look at this simple employees table. Every row here represents one employee. That's our book. And the columns, employee ID, name, age, salary, those are the chapter titles that neatly organize all the information about that person. See? It's clean, it's structured, and it's incredibly fast to search through.
All right, so we have our perfect library. Everything is in its right place. But now, how do we ask the librarian to actually find a book for us? Well, for that, you need a universal translator, SQL.
SQL stands for Structured Query Language, and it's exactly what it sounds like. It's the one universal language that you can use to talk to pretty much any relational database on the planet. It's how you ask questions, add new info, or make changes inside our great data library. And get this isn't some new, trendy technology. SQL has been the solid foundation of data management for nearly 50 years. It was cooked up in IBM's labs back in the 70s and quickly became the official global standard. The fact that it's still the king today just shows you how powerful and well-designed it really is.
Now here's the absolute magic of SQL. It's what we call a declarative language. Think of it like ordering a pizza. You don't call the pizza place and tell them how to knead the dough or preheat the oven. Nope. You just say, I want a large pepperoni pizza. You declare what you want, and you trust them to figure out the best way to make it. That's SQL. You just tell the database what information you're looking for, and it handles all the complicated behind-the-scenes work to go get it for you.
So, what does this language actually look like? Well, let's learn the basic vocabulary. It really boils down to 4 core commands.
The command you're going to use more than any other is select. This is just how you ask for information. This example right here, select ename from employees, is basically you walking up to the librarian and saying, hey, can you please show me the names of all the employees? It's that simple.
Next up, we have insert. This one is pretty self-explanatory. This is how you add a new book to the library shelves. A new employee gets hired, you use an insert command to create a new row for them in the table with all their details. But what happens when someone gets a raise? Well, for that, you use update. This command lets you go into a record that's already there and just change a piece of it. As you can see in the example, you tell the system to update the employees table and set a new salary for a specific person.
And finally, we have delete. If an employee leaves the company, this is the command that takes their record, their book, and removes it from the library shelves for good. So let's just tie it all together with our librarian analogy one last time. Select is asking to find something. Insert is adding something new. Update is fixing or changing a detail. And delete is removing something. These 4 simple ideas, they're the foundation for almost everything we do with data.
Now that we know the language, let's see where it's being used. And honestly, you might be a little shocked to find out that SQL is the invisible engine powering so much of your day-to-day life.
Seriously, every single time you do one of these things, a SQL query is almost definitely running in the background. When you check your bank balance, that's a select query pulling up your account info. When you search for a product on Amazon, that's a select query sifting through millions of items to find what you want. SQL is the quiet, super reliable workhorse that makes the modern internet even possible.
So, for half a century now, SQL has been the undisputed champion for bringing logical, reliable order to data. But today, data is exploding. It's getting way more complex and way bigger, which leads to the big question: what comes next? As our universe of data just keeps expanding, the search for the next great librarian, the next SQL, has already begun.